Okay, so this is so important, you guys. We're going to talk about exponent rules. This is our first introduction into this for you guys. You've all been exposed to exponents, am I right? Do you guys know what an exponent is? So let's look at one. What is 4 squared?
16.
16.
You sure it's not 8?
Yes. Yes.
Sure.
You're positive?
Yes.
Everybody's sure it's 16. All right, you're right. That squared means you multiply, this is called the base, and this is called the exponent, right? Or some people call that the power, right? He's got the power of 2, is 4, you know? Right? So that's the base, though. The base is 4. That means you multiply the base times itself 2 times, right? So that would equal 4 times 4. What if I did this? 4 cubed. What would that equal? Oh, by the way, this is equal to 16.
30, write that down.
Say it again.
32.
32. 4, let's try it. 4 times 4 times 4, right? Am I right? So 4 times 4 is 16. What's 16 times 4? Right? You did 2 times 16, which is 32, right? 2 times 32, then you have to do another 2 times to get it up to 4, right? So it'd be 64. Right. So that exponent, all it says is you take that base and you multiply it times itself, the number of times the exponent is there, right? So that's easy, right? That's easy. So now that I just wanted to be sure you guys all knew that. Very common mistake, just so you know. And I bet you anything, even though you guys say you know this really well, I bet you anything somebody is going to tell me this is 12 someday, or that this is 8 someday. All right? And I have this little rule. It's a very, very technical rule, a little hard to understand, but this is what it is. Never, ever, 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 ever. Whoops, no, there's no period there. Multiply exponent by the base. Never, ever, 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 ever. Never do this times this. Never, ever, ever. There is no exception to that rule that I know of. Okay? Don't do it, right? And if you just remember that, it will serve you. Now, my guess is most of your experience with exponents has been with numbers and not with variables, right? I'm guessing that some of you have had it with variables as well. But let's look at a simple situation. Let's say we have, this is our first example. We have x to the 5th times, and I think I'm going to use a different color for this, x to the 6th. All right. Now, I want to simplify this, right? I want to pull this together somehow. And it's important to notice that they are same bases. And I suspect that you learned this with math, right? So I suspect some of you guys know this real well. But there's a lot that you haven't learned with math on exponent rules. They're going to get harder fast, right? And I'll probably teach something even today that you might not have learned from math. But x, they both have the same basis. So I'm going to actually expand this. What is x to the 5th? You know, I can't multiply it and say, oh, it's 12. I can't do that because I don't know what x is. So all I can do is this. I could say x times x times x times x. Is that right? No, I got to put another one, right? Yeah, because I have to have 5 of these x's. 1, 2, 3, 4, 5 multiplied times each other. And then what do I do? This one is times x times x times x times x times x times x, right?
Yeah.
All right. So now I can simplify. I can say, how many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this equals x to the 11th. Okay? Pretty straightforward, right? Fist of 5. You guys get this? Pretty easy, right? Okay, good. So now algebra. We haven't really talked about this much, but algebra is all about shortcuts. In fact, if I had to sum up what algebra was, that's what I would actually say it is. It's a shortcut process to do a lot of computations, right? Instead of dealing with this, we have learned, oh, we can take x times x times x times x times x and turn it into x to the 5th. Much easier to deal with, much smaller, right? I mean, what if I had x to the 450th? I would be doing x's all day long if I use this method, right? Thank God for algebra, I can do x to the 450th, right? Okay, now I am going to do one thing now. I'm going to take this, well, I'll just do it here. This is equal to x to the 11th. Do you notice any pattern with the shortcut that could be a potential shortcut up here? Lucinda.
You just add the exponents together.
Yes! Look at this. 5 plus 6 equals 11. That's interesting. Now let's think about this. We are multiplying bases, same bases, x and x, that have exponents, but we're adding the exponents. And that's the answer, x to the 6 plus 5, which is 11, right? Interesting, right? You multiply same bases with exponents, but you add the exponents. You don't multiply the exponents, you add them. Okay? All right, so with that in mind, let's try a few. So here's number 2. So x to the 10th times x to the 14th. What would that equal? X to the 24. Exactly. X to the 10 plus 14, which is 24. Pretty easy, right? This is the easiest one by far. This is the easiest exponent rule. Everybody gets this really fast.
Is it like the correct way to say it is x to the 24th power?
Yes.
Okay.
Yes. You'll see it. You'll hear different people say it. X to the
I was just wondering because
Yes.
like that confuses me.
Yes.
I was just
x
figuring
to
that
the.
out.
But if you say to the, usually that means they're raising it to the, or x raised to the 24th power, or x to the 24th power. Yeah, right. But I sometimes shortcut my. I apologize, but you're right. Totally right. So what if I did this? What if I said? What if I said x to the 7th times x to the minus 5? X to the 7 plus a negative 5, or x minus 5. It would be x to the 2nd power, or x squared. Exactly. Now, my guess is most of you have not dealt with negative exponents before, right? My guess is most of you have never even seen it, right? But you're going to get really good at negative exponents with this class. Okay. Let's try another one. Let's say I had x to the 4th times x to the negative 16th. X to the negative 12, right. X to the negative 12. All right, so you guys are getting this. It sounds like you guys are getting this rule. All right, now I'm going to write the rule. Here's the rule. We're going to kind of write down a few rules today. This rule is this. Let's see here, yeah. A to the n, times a to the n is equal to a to the m plus n. Right? That's what we've been doing. That's typically how you'll see the rule. Sometimes it might be x to the m, and times x to the n equals x to the m plus n. I don't remember how I do my rules.
Yeah.
I guess I did x's, yeah.
Is this what we're having for homework tonight?
Yes, this is homework. Okay? So that's pretty easy, right? You guys are all on board with this? It's pretty easy. Now, let's make it just a little bit harder by doing something. Yes, no.
So wait, what does the A stand for?
Okay, that's a good question. That's a great question. I should explain this more. A stands for any number. But A is, these two A's have to be the same number, right? You see what I'm saying? So basically A is a base, any base number, where the the bases are the same. And then M is any exponent, and N is any other exponent. And so if they are the same bases, then the answer will be that base raised to the addition, the sum of the two exponents. Does that make sense?
Yeah.
So that's how they write this formula so that it works for everything, right? So A could be 10. I could put 10, and M could be 4. At 10 to the 4th times 10 to the N could be the 5. 10 to the 5th equals 10 to the 4 plus 5, right? Which is 10 to the 9. Question, somebody? Yep.
Like, what if it was like actual numbers, but it was like adding? Like 4 to the power
All right, that's a
7
great question. That's a great question.
plus
So
5 to the power of -5.
but same bases, right?
Yeah.
You're talking about same bases. So let's say we had x to the 10 plus x
But
to
x
the-
was, but the two x's were an actual number. What would you do?
Oh yeah.
but they were the same number.
No, it's like.
Well, okay,
oh,
hang on. Okay, I'll get there. Hang on. Just I think I know what you mean. But let me just do this first. If I have same bases, she's talking about adding these now, right? It's a totally different ball of wax. We're not multiplying. This is multiplying. This rule is multiplying same bases with exponents, right? That's when you add the exponents. But if you are adding same bases with exponents, if the exponents are exactly the same, this is really important. If the exponents are exactly the same, then how many x to the 10s do I have?
2.
I have 2 of them. So I can write it as 2x to the 10. That's okay. I have 1x to the 10. Somebody else gave me another x to the 10. I have 2x to the 10, right? Easy, right? But if I had x to the 10 plus x to the 9, those are not like terms. Remember like terms? Like terms says the x factor has to be exactly the same, right? Right? If I had 2x plus 5x, oh, they both have x's, the exact same kind of x's, x to the 1 power. Therefore, I have 2 x's, like 2 apples. Somebody gives me 5 more x's, 5 more apples. I have 7 x's, or 7 apples, right? So I have 7 x's. But here, somebody gave me 1x to the 10, which is really exciting, but then they gave me they gave me an x to the 9. I can't do any more than that. That has to stay like that. I cannot combine them. They're not like terms, right? So that was a good question. But what we're doing here is totally different because we are multiplying same bases. Notice I did not add the exponents at all when I'm adding these, right? I only added them when I'm multiplying the bases, same bases, right?
That was part of my question, but also, what if the x was a number?
So, yeah, so it's the same thing if x was a number. If I had, let me erase this one. If I had 5 to the 10th power plus 5 to the 10th power, that would equal 2 times 5 to the 10th power. But I could figure out what 5 to the 10th power is by 5 times 5 is 25, times 5 is 125, times 5 is, you know the rest, because you know your millionth times tables, right? Yeah.
No.
Okay, so no problem. But 5 to the 10th power, it'll get to be a very big number. I don't know what it's going to be. But so I could figure it out, and then we just multiply it times 2, and then, because we have 2 of those very big numbers, 5 to the 10, right? We're just going to multiply times 2, right? Make sense? Now, if it was 5 to the 10 times 5 to the 9, we could get one answer, but you'd have to figure out what is 5 to the 10, 5 times 5 times 5 times 5, and then plus what is 5 to the 9, 5 times 5 times 5, you know what I mean? And then once you get those answers, you can add them together, right? But with x's, you don't know what those are. And you never will until you solve for them. And the only way you'll solve for them is if it has an equal sign. Notice none of these have equal signs. They didn't have equal signs when I first wrote them, right? So yes, Thorne.
It's Title 5.
Say what?
It's Title 5.
Right, and the bell is going to ring later because of GOB, so you're going to have your break just a little bit later. I didn't explain that, I'm sorry. All right, so you guys with me so far, right? So we're going to make it a little harder. I'm afraid, I don't know. You know, Nate, is there any way to get any kind of judgment of like how much time I have? It's a little hard to do a lecture without knowing some ballpark.
I'll do my best.
Yeah, but if they, 5 minutes, 2 minutes, 10 minutes. All right. What if I had this? What number did I leave off on? 3, 4, 5? I'll do 5. Okay. So what if I did this? -3 parenthesis to the 5th times -3 to the 6th. What would be my answer?
It'd still be.
Say it again.
Yeah, 11, 3 or -3.
Wait, -3 so negative.
So what is my
Positive.
base? What is my base?
3. -3.
-3. Notice the
It'd be 3 11s because negative times negative.
10 minutes? Oh, good. 5 to 10. Okay, got it. Okay, perfect. That helps. All right, my base is actually -3, right? They have the same bases. And does the exponent affect the 3?
Yes.
Yes, because the exponent affects what it's next to. What is the exponent next to? It's next to a parenthesis, right? That means it affects everything inside that parenthesis. Does that make sense? Henry, you get that?
Okay.
If that exponent is next to a parenthesis, it affects everything inside the parenthesis. So it means it's -3 times -3 times -3 times -3 times -3, right? So my final answer is -3 to the 11th. It's the same thing. I didn't do anything different, right? It's just same bases being multiplied. I just add the exponents. Piece of cake, right? Question.
So it still would have been the same answer if you had gotten rid of the parentheses and then did -3 to the 5th power, and then like same thing with the
No,
6.
that's a great question. If I did this, -3 to the 5th times -3 to the 6th. Remember, the exponent only affects what it's next to. It is next to a 3, not the negative. It is not next to the negative. It does not affect the negative at all. Now, I could actually multiply, let me think about this for 1 second. If I did it this way, I just want to make sure it works both ways when I do this. So that would be negative, and that would be positive, would be negative. And that does not make sense. Oh wait, yeah, that's right, because I'm thinking of it that way. Okay, so since this does not affect the negative, negative times negative is a positive. Negative times negative times negative is a negative. Negative times negative times negative times negative is a positive. Okay, look at that. When you have an even number of negatives being multiplied together, they turn into a positive, right? An even number.
Oh, so it'd be +3.
I have an even number. I have
11.
negative times negative. I could actually take that negative and multiply it times that negative right now because they're not being affected by the 5 or the 6, right? It's kind of this is
So
the hard.
it would-
This is confusing to people.
So it would be 3 to the 11th because the -3.
It
times
would be
negative
exactly
3 is
because this I'm going to there's a rule that says if I'm multiplying things, I can move them anywhere I want. Like if 1 times 2 times 3 is also 1 times 3 times 2, or 1 times yes, it's called the commutative property because they can commute. Did I teach you that, or did you learn that somewhere else?
You got it.
Yeah.
I did. Did I teach it to everybody here? Oh, I did. Okay, great. So A times B times C is equal to A times C times B, or C times B times A, or C times A times B. It doesn't matter what order it is, right? So it's negative times 3 to the 5th times negative times 3 to the 6th. So I can put the two negatives together. Negative times negative is a positive. So then I know it's going to be positive, and then it's 3 to the 11th. See how that is? This will definitely, will this be positive or negative if I multiply that out? It has an odd number of negatives, right? It's going to be an odd number, so the odd number will give you a negative, an even number will give you a positive, right? Does that make sense? Odd number, because negatives on negatives is positive, times negative is negative. Times negative is positive, times negative is negative, times negative is positive, times negative is, so I mean, you can go, keep going. But it's easier to just do it that way. Okay, we got to learn another thing. If I did, oh, wait, one more thing, 6. Let's do one more thing. Let's say I had x to the 4th times y to the 10th. What would that be?
X to the 4th plus y to the
It would be
10th.
like x.
Would it be
Y.
x times,
Or no.
it would be x times y to the 14th.
No, it'd be x, 1x or 1x to the 4th times 1y to the 10th.
Right, it would just be what it is.
Yeah.
It's just x
Yeah.
to the 4th times y to the 10th. They are not same bases, right? I cannot add these. They're totally different bases. I can't add exponents. I just have to leave it the way it is. It's just x to the 4th, y to the 10th. That's all I can do. I cannot combine it. This rule is only when you're talking about same bases, right? So what if I gave you this? What if I said this? X to the 5th times y to the 7th times x to the 11th times y to the negative 2.
You can just add the y's and add the x's.
Yes, I can take the x's first, right? I've got x to the 5th times x to the 11th. So that's x to the 5 plus 11, right?
So that would
Times y to the 7 minus 2, right?
so it would be
So y to the 7
x
minus
to
2.
the
So what would that equal?
16th, x to the 16th times y to the 3rd.
Wait, Gary, what's this? The
fifth.
x to the what?
Right? This? Oh, that's not clear, is it? Sorry. 5, right?
Yeah.
5 plus 11.
Oh.
None of that looks clear, does it? 5 plus 11, right? And
Yeah.
5 plus 11 is 16, so it's x to the 16 times y to the 5th, right? Okay, so fist to 5. You guys are all with me on all this stuff? This is easy, right? Now, sometimes, though, you'll get this. Every now and then, well, let's do this really fast before I go there. I forgot what I'm on. 7?
So you're on 8.
I was on 8? Okay. Okay, 8. Do that again. All right, what if I did this? 5x squared. Now, what is the exponent next to?
Parentheses.
It's next to the parentheses. So that means my squared affects everything. So that means technically this is what it means. It means 5x times 5x. Don't you agree with me?
Yep.
The squared affects everything. That means I'm going to multiply that times itself 2 times. That's what squaring is, right? 4 squared is 4 times 4. 5x squared is 5x times 5x. Which is, what's the answer? 25x squared, right? You with me? 5 times 5 is 25. X times x is x squared. You with me? Pretty straightforward. Try this one then. How about 6x squared? What would it be?
36.
Yeah, it's basically 6 squared times x squared. And 6 squared is 36, so it's 36x squared. With me? You got it? Right? So the squared is next to the parenthesis, right? So it means I'm squaring this entire thing. So I'm going to square the 6, and I'm going to square the x. So 6 squared is 36. x
So 6
squared
times 6
is x squared. So 6 times 6 is 36, right? Now, there's a rule that it discusses. This is a rule. If you have a times b raised to the n power, it is equal to, it's the same thing as a to the n times b to the n. Does that make sense? If I have two different numbers, like I have here, I have a 5 and an x. 5 is the a, and x is the b, and I raise it to the second power, or to any power, then the answer is a to the n times b to the n. Make sense? So that rule tells you how this works right here. There's one last rule that we have to cover today. So if the bell rings, actually don't let anybody let Nate out of the room, okay? That would be the easiest thing. Just don't let him out of the room. Okay, Evan? Don't. You know Tai Yi, right? Ah! Don't you dare. Okay. Right, okay. 9. 9. What if you had this? We did a couple of these before, but what if you, well, no, maybe we didn't. I don't know. What if you had this? X to the negative 10 times x to the 5. This is just a straightforward one like I taught right in the beginning. So Weston.
I know.
X to the negative 5th power.
X to, yes, it would be x to the negative 10 plus 5, which is negative 5, right? You with me? X to the negative 5. Okay, so that is the right answer, but in math, there is a rule. And this rule says never leave your answer with, if your answer has a negative exponent, do not leave it in that form, right? You're not supposed to leave it with a negative exponent. So yes.
I was gonna ask, back on 8, when it
Yes.
says equals 36x to the second power.
Yes.
Why wouldn't you do 36 times 36x?
Yeah, so you wouldn't have to do the second power.
Why? Say it again. Why would you what?
Why if there's an exponent there, why couldn't you do 36x times 36x?
Because
Because
you don't have 36 here. You have just 6 here. So it's going to be 6. The squared means 6 times 6, right? And then the squared means x times x. 6 times 6 is 36. You see what I'm saying? Make sense? All right. But so for this one, you're just adding the exponents. Your same bases, you're multiplying. Therefore, you add the exponents. You've got x to the negative 5. Yes?
Then wouldn't it be negative 5 times x to the 5th power?
For this one?
Yeah.
Negative 5 times x to the 5th. No. But I'm going to write the rule first now. Watch this. Okay, this is the rule. A to the negative n is equal to 1 over a to the positive n. Look at that. This is weird. This is weird. But eventually I'll show you why. I don't think I'm going to show you today why. But, so I'm going to erase, well, I guess I'm still working on this one. So we've got x to the negative 5th. X is the a, the negative 5th is the negative n, right? And it's just saying that if I just turn it into a fraction and put this in the denominator under a 1, that's what this is saying, then the exponent becomes positive. That's all it's saying, right? So it's saying this. I could write this as 1 over x to the positive 5. And that's the correct answer. Does that make sense? See, I told you guys haven't learned this stuff, right? This is the beginning.
That looks scary.
It looks scary. So let's practice that one, since that one looks scary. I'm going to erase this stuff up here. We'll just practice. I'm going to just, okay. So let's practice this. Let's do x to the negative 11th. is equal to x to the negative 11th is equal to what?
X to the negative 11.
Yeah, and the other way is 1 over
X to the negative 11.
x to the positive 11.
Positive.
Yeah, it just makes it positive, right? X to the positive 11. And I'm going to explain more about this in a few minutes, but watch this. So we got x to
So
the
you're basically multiplying it by positive 1.
x to the negative third. Well, positive 1 times this would be just this. 1 times this would be what?
Then wouldn't
one
it turn
times
into a
anything.
positive if you multiply it by a positive?
Say it again.
Wouldn't it turn into positive if you multiply a negative number by a positive, like 1
No,
times?
negative times positive is negative. So it'd stay negative, right? But you're not, a number here does not affect this number here. A sign here would not affect this sign here. You know what I'm saying? If I were going to say negative 2 times this, all it would mean is I would have negative 2x to the negative 11. Then you'd have 2 of them instead of 1 of them. Negative 2 of them, right? It'd be a nightmare, right? But so x to the negative 3 is the same as 1 over x to the positive 3. X to the negative, 15th is equal to 1 over x to the positive 15th. This is another way I sometimes teach it, because this is useful because it works backward too. But watch this. If I had x to the negative 6th, how could I write that as a fraction without changing it and without using this rule? How could I turn? You can turn anything into a fraction by putting it.
X over negative 6.
You can put. How could I write 4 as a fraction? 4
Yeah.
over 1. How could I write that as a fraction?
X
X
over negative 6 power over 1.
Yeah, x to the negative 6 over 1. So watch this. This is really what this rule is talking about, that it doesn't explain very well. This rule says, and what is the number in front of the x?
1.
There's a hidden 1 right there, right? So I'm going to write the 1 for now. Does the negative 6 affect the 1? No, because there's no parenthesis. It's only next to the x, right? So it's x to the negative 6. That's the stuff that the negative 6, the negative 6 is only affecting the x. There's still a 1 there. You with me? You with me? Henry, you get this? Really important to listen here. If I take if I circle the negative exponent and only what it affects, and this is my fraction line, if I bring it down across the fraction line, it changes that exponent to a positive. So suddenly, look what I have. I still have that 1 upstairs. The x to the negative 6 comes downstairs, and it becomes x to the positive 6. And that's what this rule is actually saying. Does that make sense? So whenever you have an exponent, a base with an exponent, and you move it across the fraction line, the exponent sign changes. I could turn a positive to a negative by just moving it across the fraction line. And it works going up as well as going down. If I had 1 over x to the negative 10th, I don't want to leave my answer with a negative exponent, right? I look at, okay, well, what do I have? I have x to the negative 10. The negative 10 affects the x. I'm going to move it upstairs, right? And then I have x to the positive 10. I could put it over 1, but I don't need it, right, over 1, because anything over 1 is just it. So that's it. Those are what you needed to know for the homework tonight. And that's the end of the lecture.